All right. I want to show you guys an example of a schematic that we could use for our battle bots. So let's take a look at this one. So what you guys can see here is there is the battery. I'm going to pop out my annotations. So you've got the battery over here. And then we've got our motors, which are connected to the motor controllers. Two of those, one on either side. And then we've also got our key switch, of course. There's the LED light that we need to have as an indicator for when the robot is on. And then we have the power going into the motor controllers and then back out of the motor controllers and back to the battery. So if I were to show you guys the flow of current, remember that current has it flows in the direction from negative to positive. It's the flow of positive charge. So if I were to draw the flow of positive charge, it's going to come out of the positive side, so flows positive to negative. It would flow into our switch, which is very, very important. And then it's going to split off. Part of it is going to go into our light, and then part of it is going to come down here to the motor controllers. And then it's going to split again. So we're going to split off. Part of it will go to one motor controller, and then part of it will go into another motor controller. And from there, we would have to have the electricity go into the motors, and then it would actually come back out of the motors, back to the motor controller, and then back out here. So same thing's going to happen on this side, into motor, out of motor, and then back out here. And then we can have that come back together and come all the way back to the battery. And then the same thing, we've got our light. The electricity does have to come back out of the light as well and flow back into the battery. So that's the flow of current, which is the flow of positive charge. However, if we clear all those drawings, what's actually flowing is negative charge. The thing that actually flows is electrons. And so what that's going to be like is if we have our little electrons, I'm going to draw them as little dots because they're basically little dots. They're little negatively charged dots. And since they're negatively charged, they're going to be coming out of that negative end of the battery. And then they would be able to break off, and we have a group of them flowing into the light, allowing our light, our LED, to emit some light, and then coming back in here, back in through the switch, and then back to the positive end of our battery. Whereas we've got some other electricity that's going to be going around, breaking off into the motor controllers, back out into the motor, and back into the motor controller, and then back up these branches, as you guys can see. So then just right back, so through here, out to the motor, back into the motor controller, and then back up to the switch, and then back. And so that's going to be the path that it will take. Now, if you guys will take a look at this piece. So this is an example of a simulation. Oop, I need to get rid of all of those little electrons. There we go. So in this simulation, you can actually see the electrons that are going to be flowing through this circuit. So when I close the switch, you can see that the electricity is flowing through my light bulb. Right now, there's a tiny amount of electricity that is still flowing through the motor controllers, but I added these switches here. And the reason that I added these switches um, with with these two pieces here. So this is supposed to represent the motor controller. This object here represents the motor controller, and this represents the second motor controller. These represent the motors. And the reason that I have another switch here is to just try to represent that um, the motors are only going to be getting current when this object, the motor controller, allows electricity to flow through it. So it's not a perfect representation of the motor controller because really the motor controller is allowing not just on or off, it's not just a switch, it's allowing a complete range of increasing and decreasing that voltage and increasing and decreasing that current. So it's not a perfect model to represent a motor controller, but it's at least better than not having anything there at all. So then if I close both of those, it's like both of the motors are able to turn at the same time. If I have one of them open, then only one motor is going, and vice versa. I can also click on these motors and control their resistance. Right now, this is really, really high, that motor controller. So if I decrease that, then you can see that more electricity is able to pass through the motor controller. So I'll just decrease that as well. The stripes on there are actually the way that a real resistor would be striped to indicate how much resistance it has. So that's kind of fun with this little simulation. And so you can see when I have the switch closed, when it's open, nothing's moving. When that switch closes, then we do still always have electricity flowing through those motor controllers, which is why as soon as you turn your robot on, you hear the little fans in the motor controller start up, and they might even chime a little depending on the type of motor controller you're using. But the motors themselves aren't necessarily going to be turning because the motor controller controls when electricity is going to be moving through it. And so that is how we can show that variation. I just used the little switch there to help represent that variation. Okay. But you can see there's very little electricity going through there because there's still quite a bit of resistance. If I decrease that, we might be able to see them move a little bit more. Increase that one a little bit. Get a little bit more of them starting to go this way, but there's a lot of resistance there. So like I said, it's not a perfect model, but it is a good example. We can also show the conventional direction of current. So see here that it's going from the positive side back to the negative side. One thing that I don't love about this is it shows it continuing to go from end to end of the battery, and that's not really accurate because this kind of makes it look like the battery has a never-ending supply of power, which it doesn't. Really, eventually the battery is going to run out. And so as we continue having electricity go around and come back to our negative end of our battery, it should stop there because the battery itself, it's allowing a chemical reaction to occur. And as that energy is flowing, eventually the chemical energy runs out. And so eventually we would have all of these arrows go through this circuit and then they would end up over here and it would be done. And that's when your battery would be dead. It would be out of power. It would be out of electric potential energy. And so that's also not a perfect example in this particular model, but does show a good approximation for how we can represent the schematic. The last thing that we can do here is, I'm going to go ahead and take off the current because we don't really need to see that right now. But I'm going to show you guys, this is these are the schematic symbols for these different parts. So you can see there's a shape for a light, and we're actually going to use something that's different to represent an LED light. There's a shape to represent the power source over here. Represents the switch, open and closed switch. And also here, open and close switch. And then you can see the resistors are just these zigzags. And then all of the wires are just straight lines. And so then that's a little introduction for what's going to come next, which is how do we actually draw a real schematic with the correct symbols. Okay, that's it for right now.